I'm working on broadly in the field of neuroengineering, and recently we are focusing on developing a novel dynamic brain imaging technology, or sometimes called functional neuroimaging. And different than the functional MRI or other imaging modality is we use electromagnetic signal. So we put a cap over the scalp to record a multi-channel electric signal. It could be magnetic signal, reflecting dynamic, instantaneous, and brain activation. And from there, our innovation is to develop a machine learning and signal processing algorithms so we can project back from surface of the scalp and to inside of the brain to show that how three-dimensionally, how the neural information processing propagation is going to be occurring, to understand how the cognition, perception, and the various motor function. And most importantly, it has important clinical application, such as in epilepsy or depression or pain, or in various neurological and mental disease. The impact of this work, I think, has twofold. One is to establish a fundamental technology. That is, in the neuroimaging, we all know CT, PET, MRI are all there. But all of these technology cannot provide high spatial and temporal resolution imaging of the brain function. Our technology is aiming at become one of such that doctor can prescribe from an array of electromagnetic recording to provide a dynamic brain pictures. There are many diseases. For example, we look into stroke, we look into pain, and most importantly, we look into epilepsy, a disease that impacting 70 million people in the world. So if this technology eventually fully developed, it could make the epilepsy surgery into potentially in one day. We are not just working on math or signal processing or machine learning algorithm alone. We are solving a real problem. And therefore, it's really highly interdisciplinary work. And we are very fortunate to have very strong collaborator at the Mayo Clinic. And I have built a very strong collaboration with the UPMC, and we have been collaborating over the past 4 years. It's always hard to predict exactly when the research will go to work. I think there's two sides. One is the research side, and our recent progress has demonstrated this technology. On the other hand, is a go-to practice that depends on whether there would be commercial entity or company is going to license the work. I just really wish to see this technology is going to go to help a patient. And I believe our technology at this time representing the best in the field.